Jess drops vertically onto the other end, causing Hannah to be thrown into the air. When Jess lands on the seesaw, Hannah is thrown into the air at a speed of 15 meters per second at an angle of 70 degrees to the horizontal as shown in the diagram. Calculate the time that Hannah takes to reach the highest point in her trajectory. Okay, so when you're considering this, you only want to deal with the vertical component, the vertical up and the vertical down. In fact, just the vertical up, because it's to the point, the highest point in the trajectory. And you uses the equation VF equals VI plus A times T. We're looking for T. The initial velocity is going to be the vertical component of this. So that's 30 degrees. So let's see with our triangles. We've got that what we're trying to find, that's what we've got. So that's 15.0. There's the angle. 15.0 is the hypotenuse. And I think we're using cos theta, which is 30 degrees, because it's from the 90 degrees minus the 70. In fact, that's 20 degrees. Cos 20 degrees equals the adjacent, which is what we're trying to find, which is VF, over the hypotenuse, which is our 15.0. So 15.0 cos 20 equals VF. We plug that in, equals VI, I should say. VF equals 0 at the top, so 0 equals 15.0 cos 20 degrees. And we want, it's plus AT, so we're trying to find the time. A is the acceleration downwards, so it's going to be a minus. I don't know if that's going to matter actually on this, but minus 9.8 meters per second. And we're going to end up with, when we rearrange this, we're going to end up with T equals 15.0 cos 20 degrees divided by 9.8, and that's going to give you a time of, I don't know, but you can calculate that yourself. When Hannah takes off, the horizontal component of her velocity is 5.1 meters per second. State the size and direction of her velocity at the highest point. Okay, so at the highest point, right up here, your vertical velocity, if you're considering the vertical direction, is 0. So the only velocity, her total velocity at the highest point, is just the horizontal velocity, which is that 5.1 meters per second to the right. So the size, 5.1 meters per second, and direction to the right. Okay, right. And when you explain it, you explain that the acceleration vertical direction leading to 0 velocity at the peak of her flight at the apex, and the only remaining horizontal velocity is her velocity.